I never did a recording of notes 10-1, but to do these notes you need a paper that I have to give you in class. So if you haven't gotten your paper yet from me to take the notes on, get it from me before you watch this video. So notes 10-1 starts, it says Honors Secondary Math 2 at the top, but it starts with a big graphic organizer on the front page. And that organizer is set up to do the example given. Today for lunch you decide to go to a deli where they offer sandwiches on white, wheat, or rye bread. You have a choice of turkey, ham, or roast beef, and a choice of cheddar or provolone cheese. How many different types of sandwiches could you make where you choose one type of bread, one type of meat, and one type of cheese? So I'm going to start you on the graphic organizer, and then I want you to finish it yourself. So it starts with some boxes on the left. And there's 3 boxes. And then they have stuff branching off from them. So in those 3 boxes is your first choice. When you're deciding to get a sandwich, your first choice is usually what kind of bread. So we have white bread, wheat bread, we have rye. So you go through and you say, okay, well, my second choice I can make is meat. We have turkey, ham, or roast beef. Well, I can choose a turkey sandwich on white, or I could choose a turkey sandwich on wheat, or I could choose a turkey sandwich on rye. So I have to use turkey a couple of times. Same thing goes for ham. I could choose ham on white, or ham on wheat, or ham on rye. So we'd have to use ham a couple of times, and roast beef a couple of times. Then you'd finish off your last choice with your cheese. Once you've filled out the entire organizer, then you can figure out how many choices of sandwiches you would have possible. So on your own, I want you to finish that organizer and count up how many sandwich choices are possible. So on the next page, it starts talking about something called permutations. And it has an activity that we did in class. You won't do the activity at home. But it says, how many different ways can you line up 5 different colors of Skittles? So let's say we have red, yellow, green, purple. I forgot what the last color was, so I'm just going to say blue. Okay, again, we want to try and figure out how many different ways could I line this up. So one way I could change this is I could change what's in front. Maybe I want to do yellow, red, green, purple, blue. Hold on 1 second. Okay. You wouldn't have noticed an interruption because I paused the video, but that's why I said excuse me for a second. So, question 1, we were deciding the different orders. We could change the different way we arrange the colored Skittles. We could keep doing this for a while. You could keep listing this over and over and over again. But there's a quicker way. So, when you are trying to figure out how many possible ways to arrange all these 5 colors of Skittles, you would start with looking at the first line here and saying, okay, I'm picking my first Skittle. How many Skittles do I have to choose from? Well, we had 5 different colors of Skittles, so I pick 1 Skittle. So one of those would go away. It doesn't matter which one. We just say, okay, 1 went away. So now I need to pick my second one. My second one, how many colors do I have left? Well, I have red, green, purple, blue, 4 colors left. But then I pick one. So now I have 3 colors left. Then I pick one. I have 2 colors left. 1 color left. If you multiply all those together, that gives you the total number of ways to arrange this. But we needed a new notation. The new notation is that exclamation point, which we call a factorial. And it means to multiply as you count down. So if we multiplied it all out, it would be 120. So if you look at question 2, question 2 just wants you to line up 3 of the 5 Skittles. So when we pick our first Skittle, we still have 5 Skittles to choose from. We still have 5 different colors we're working with. And then 4, and then 3. But we don't use the last pieces because we only wanted to pick 3 of the 5 Skittles. So this would tell me how many ways I could arrange 3 Skittles if I picked those 3 different colors from 5 total colors. Question 3 is the same idea. Question 3, write a CRT review quiz, or with a CRT review quiz, how many different ways could you arrange 4 questions from the 9 topics? Well, we have 4 lines because we're picking 4 questions, but we would start with the number 9 because we have 9 total topics to choose from. So we have 9, we picked 1, which means there's only 8 topics left. We picked a second one, so we have 7 topics. And then we would multiply all of this out. 9 times 8 times 7 times 6 would give us 3,024. Now this time I couldn't use my factorial notation because we didn't go all the way down to 1. So on part 4, ignore what the sentence says and just use it as a space to write some of these notes. Well, we want to be able to figure this out all the time using a formula. So the formula that was discovered for this was called a permutation. A permutation is the number of ways to arrange items when order matters. We had a new notation for this and its associated formula. So NPR means P is our permutation. A giant P stands for permutation in this case. N is the total number of objects, and R is how many we are choosing. So the formula is n factorial over n minus r factorial. So if we looked at question 3 again, but this time we used our formula, our total number of topics was 9, so we'd have 9. We're performing a permutation because order mattered, and we're choosing 4 of those topics. So now we'd plug them into our formula. N we would replace with 9. The second N we would replace with 9, and the R we would replace with 4. First, we subtract our 9 minus 4, and then the 9 factorial divided by 5 factorial you would plug into a calculator. You would hit the 9 button, the factorial button, divided by 5 factorial, and then the equals button. Now, we already know the answer to 3 because we've done it a different way. It should come out as 3,024 when you plug it into your calculator. So if you turn to your next page, we can talk about combinations. Combinations was the same concept, but this time we're going to say order doesn't matter. Now, order mattering is going to be the hardest part on this. You have to figure out what does it mean by order mattering and order not mattering. So, let's take some situations to give you an idea. If you were to run a race, running a race, the order matters because first, second, and third count differently. So if you have 8 people running a race and you want to pick how many ways could 3 people win, how many arrangements could we have, we would use a permutation. Combination would be something like a reading list. Let's say your English teacher assigns you a reading list. They want you to read 4 books over the summer and you have 12 books to choose from. Well, that would be a combination where order doesn't matter. So we're going to skip all the way to 6. 6, it gives you the formula already, but we need to change this to say NCR. And this formula works when order doesn't matter. So if we took that same question, write a CRT review quiz, how many different ways could you arrange 4 questions? If we don't care what order those questions are in, we had 9 total topics, 4 that we were choosing, then we'd end up with this. Now again, we need to know how to plug this into our calculator. So calculator-wise, we're still going to be using the factorial button, but because we are dividing by a whole bunch of stuff, we need to put in our own parentheses. Otherwise, it's going to come out as the wrong answer. So we'd have, in the calculator, we'd hit the 9 button, and then equal button is not used. 9 button, factorial button, divide by, parenthesis, 4 factorial times 5 factorial, end parenthesis, equals. So when order doesn't matter, we actually have less choices. So it should be less than what we got on the previous page. There's only 126 ways when order doesn't matter. So you have the 2 formulas. You have the permutations and the combinations. Permutations is when order matters. Combinations is when order doesn't matter. So the last page was your assignment, but let's just talk about the different ways we can mean order or not needing the order not mattering. So if you look at like 10, the Mesa Club is electing the president, vice president, and treasurer. How many different ways can the officers be chosen from 30 members? Well, president, vice president, and treasurer, they all have a different amount of power. So picking the first person as president is different than picking the second person as vice president. So 10 would be a permutation. You would use the P formula. We have 30 total members, and we're choosing 3. So you'd go through and plug that into the formula we have for a permutation. If you look at 12, 12 would be a combination. This was like our English teacher asking us to read so many books over a summer. So combination-wise, we still have 12 total books. We're choosing 4. It doesn't matter what order you read them in. So then you need to finish the rest of the assignment and turn that in as soon as possible to get the full points.